Good afternoon, everybody. I am Jack Lazarchuk, and I'm a developer at Chariot Solutions. I doubt anyone would disagree that Kotlin is one of the fastest growing languages, since just under a year ago, Google announced that it would be the preferred language for Android development. A change of this size is going to cause a paradigm shift in the design patterns of an Android application. MVI is more than just Roman numeral 1006. It stands for Model View Intent. Etienne, Caron, a developer at Shopify, is here to tell us about this new pattern and how it works with Kotlin Coroutine and flows for Android development. Before I hand things over, I'd like to take a second to thank both Etienne, everybody watching, all the sponsors, everybody involved in this. I've had a great time with this, actually. I've been pleasantly surprised. So though it's unfortunate we can't meet in person this year, I'm still very glad we're able to do this and spend this time together. So thank you all very much, and off to you, Etienne.
Thank you. Hello, everybody. So nice to meet you all. So my name is Etienne. Let me just adjust my thing. So yeah, I'm Etienne Caron. So I need to thank two more sponsors that sponsored my time to prepare for this talk and also provide a lot of support when I go and talk virtually at conferences. Shopify, my employer, who reserved some time for me to get ready for this, and also the Google GDE program. So Google helps out the community a lot, and I'm part of the lucky folks that Google backs in these efforts. So thank you to both, and a huge shout out to all the conference organizers. I really admire the great work they've done in making this event happen. All right, so let's get started. Today we're going to talk about the MVI pattern and how to use it with a more Kotlin purist approach with coroutines and flow. So for me, I discovered the MVI pattern a few years ago on Hannes Dorfman's blog. So the general idea is that user views generate UI view events. Those will be converted into something called intents. And these intents are effectively declarations of what you want, the work you want to get done, and the manipulations you want done onto your model. So those are applied to your model. And when you get changes to the model, the other way around allows you to effectively broadcast these changes back to the view, and you get the whole cycle that we see on screen here. So before we go into more details, what's so special about this pattern anyway? So there's a few key features. One of them is that it relies strongly on functional programming principles. So if you look at mathematics, functions have important properties that we want to carry over to our program. Put very simply, when you call a function with a given x, a given value x, you expect it to always give you the same result back. And also when you call a function in mathematics, it should effectively be side effect free. So you want that for your programs as well. You want something that allows you to call the function, get a result, and not have any side effects that might shoot you in the foot a bit later, or, well, you see what I mean. All right, so one nice way to mostly get rid of side effects is by making our function arguments and return values immutable. So in object-oriented and functional programming, an immutable object is an object whose state cannot be modified after it's created. So that's in contrast to a typical mutable object, which can be modified after it's been created pretty much anytime you want. So another key feature of MVI is that it relies on reactive programming principles. The nice thing with reactive programming is that it allows you to break down complexity very nicely. So you focus on one problem and one task at a time, and then you get to compose your logic in very flexible ways. So for a few years now, I've personally been using RxJava as my reactive stack of choice. I like how it allows for safe parallelization of work. It also gives you a super powerful API to manipulate streams of events. It gives you a lot of control over threading, so you can offload work, heavy work to the CPU or IO dedicated threads pretty much any way you want, and then keep some other things on the main thread for view rendering and things like that on Android. RxJava is a great library. It does come with a few caveats, though. So it has a pretty hefty learning curve. When you're new to it, it'll often seem like witchcraft. The barrier to entry is high enough that you'll discourage a lot of developers with it. And that can also make it hard to adopt at an organizational level, right? So when you have hundreds of developers, if you pick a library like this, you might have a hard time just making sure everybody's on an equal footing using it. Library jar size, if you look at RxJava, including, say, Rx Android and Rx Kotlin in our case, you're going to end up with something that weighs about 2.4 megs. Nothing huge, but it's still significant size. If you're trying to build an instant app, for example, on Android, it can easily bring you over the limit. Also, lifecycle management can be challenging with RxJava. So lifecycle is something super important on Android. And with RxJava, you need to keep track of subscriptions, make sure to dispose of them when you're done. All of this is usually simple enough, but again, if you think about the Android lifecycle, when you have to keep track of each individual subscription, make sure you subscribe and dispose of them at the right point in the lifecycle, so on and so forth, it's kind of easy to make a mess of things and start leaking subscriptions. So we're going to see how that compares to using coroutines and Flow as your reactive library. So I always thought that Coroutine and Flow sort of sounded like an 80s detective team-up thing, so that's the reference there. Anyway, so thanks to coroutine scopes and structured concurrency principle, the story around the lifecycle management is really good with coroutines and Flow. You still need to be deliberate about managing the lifecycle of certain things, but coroutine scopes are going to help you in a lot of right ways. Weight-wise, coroutine core and Android dependencies weigh in at about 1.5 megs. So we save a good bit. It's not that big of a saving, you might be thinking, but it's worth remembering that if you are using RxJava in a Kotlin project, which is pretty much a de facto type of project you're going to start these days, you're going to end up most likely with both dependencies. So at that point, RxJava is sort of starting to look a bit heftier, right? Okay, so there's the wizardry factor, if you want to compare those two. Coroutines are very new for a lot of people, including me. So like a lot of things, it will feel magical at first. You're not going to be super familiar with the pattern. So is it easier at the end of the day to learn coroutines and Flow over RxJava? I don't necessarily think there's a clear winner here. The real question I do think should be, is it worth your time to learn this thing? So both RxJava and coroutines, let's say, have hefty learning curves. But if you're really interested in the Kotlin ecosystem, coroutine knowledge will carry over long term. You'll be able to use it on multi-platform, on iOS, on Kotlin native as well, things like that. So that knowledge will pay off a whole lot more, most likely, than a super precise pointed expertise with RxJava. Okay, so getting back to reactive programming as a concept and tying into MVI as an architecture. Reactive programming is a type of programming that's concerned with data streams and the propagation of change. So what does that really mean for an app developer? So if you think of a mobile app as a reactive system, the app first renders to the device screen. Then the user thinks about a moment about what they've seen on that screen, right? They're like, okay, I've seen this. They're basically inputting visual information. In reaction to this, the user is going to start pressing button, entering text, dismissing dialogue, so on and so forth. So finally, these touch events are passed back to the app. It will update its internal state, it updates the display, and so on and so on. So the user's input, if you think about it, are what drive everything in this model. Whenever you hear about you hear the word reactive, just think back to this simple diagram and this interaction. So if we translate this idea to MVI, you can almost think of the view as a placeholder for the user, right? It's the thing that will display the data to the user, and it's also the thing that receives the events. So these view events coming in are going to be translated in our model to intents. These intents will be processed by the model, and when a model updates itself, that will then be passed on to the view, which will render on screen, and so on and so forth. All right, so we're going to start digging in a little bit. So this here is our sample app. I've called it upvote. So in this app, when you press a button, it will increment a hearts or thumbs up counter. When the user presses the button, we emit what we'll be calling a view event. That will trigger this whole intent to model to view loop. And as you can see here, our screen counter will get updated. So pressing it again, counter goes up by 1. All right, so what is the view sending out exactly in this case? How are we going to handle this? So to keep things nice and tidy, you typically bundle up all the types of signal that you get from one view into a sealed class in Kotlin's case. So here I've called this class main view event. We have only 2 possible view events here, 1 per button. All right, so By using Kotlin Flows, we can generate asynchronous streams of value. Here I'm stealing an RxJava convention. If you've ever used RxJava, you've probably seen these before. Marble diagrams. They're super useful to visualize streams, and I really think they help just getting a better understanding of reactive programming in general. So if you think again of the view as a source of events, every time the user presses a button, we want a new event to be emitted downstream. So on Android, clicking handling, though, is done by event handlers. So how do we build a stream out of a callback-based system? That's the real question that we're going to have to answer. So here we click, and we want this stream to be built up. This is the marble diagram right there. All right, so if you're not familiar with Kotlin's Flow class, we're taking a quick look at it here. Flow will help us carry our stream of view events. By definition, flows are called asynchronous streams. This is slightly different than some of the stuff you'll find in RxJava, but the concepts are very similar. So by converting a Kotlin sequence of 1 through 2 through 3 into a flow, then we can collect it asynchronously. So this piece of code right here, what it will do, as you might expect, it's going to print out the numbers 1, 2, and 3. So the thing that's worth noting here is that when we say asynchronous, the call to collect that we can see here, it's important to note that in this small example, it's a suspending call. So it needs to happen in a coroutine scope. Here, if you see the block code run blocking, that provides us with a coroutine scope. So going forward, I'm going to assume some knowledge of coroutines and streaming APIs. So I know that this conference is a bit larger focused than an Android conference, so you might not be familiar with these things. So I'm expecting that if people have questions, just shoot them in the Slack channel, and I'll be just dropping a few links to learning material that can get you started. All right. So from there, so we collected, and as I pointed out earlier, this is happening within the coroutine scope, which run blocking is providing us. Okay. So how do we build a flow that allows us to turn button clicks into a stream of click events? So we're going to build ourselves an extension function on top of the Android View class. If you're not super familiar with Kotlin, you might have seen these in C#. Like the idea of an extension function is that you can add functions, so to speak, on top of an existing class without necessarily extending it, right? Okay, so here by building an extension function called clicks, we'll return a flow of units from our given view. So the idea is that every time a user clicks on a view, a unit will be emitted over the stream. If you're new to Kotlin, again, unit is somewhat equivalent to Java's void. That might seem a bit odd at first, a stream of voids, a stream of non-things. But if you think about it, it makes sense. Android clicks themselves don't actually carry any extra data. The only thing you need to know about them is that they actually happened. So by emitting a unit, we just basically telling the system something happened, and I don't have any parameters to give you, but you need to handle this. All right, so we can create a flow that is going to bridge the callback world with our streamable reactive world using the callback flow function that Kotlin provides us with. So callback flow itself, the block of code that we will provide it, will get access to a producer scope. Now, from within the block, what we'll first do is we'll create a view on click listener. This is the typical function that we pass to Android to handle a click. And then the next thing we do is that we actually assign it to our parent view. Another thing to note here is that, of course, we have access to the producer scope, right? Thanks to the callback flow function. But since we're an extension function, we also get access to our parent view code. So that's how we can call set on click listener within this extension function. Okay. So next up, I want you to note the offer call that's right there in the click listener itself. So the idea is that each time the user will click the view, we will call this offer function with a unit. If we were dealing with, say, a text box that we were editing, we'd be sending over the information. But in this case, like as I mentioned, it's only a click. There's no info, so we send a unit. The offer function is provided by the producer scope. So the idea is that under the hood, as you can see, producer scope implements both a coroutine scope and something that's called a send channel. So a channel, you offer things over the channel, somebody else can listen to them. And by doing this, we turn our click callbacks into a stream of click events. So the last step that's important when you're doing a callback flow is to always call await close. This is explained in the documentation, the Kotlin documentation there, but the general idea is that without this, the flow would immediately terminate. What you want to be doing is by calling await close, you're effectively saying execution here will suspend, and we'll only continue this coroutine when the flow consumer is canceled so that we're done with the flow. And as part of the wrap up, we're going to clear the set on click listener and set it to null. So it's worth noting that this approach, I pretty much copied originally from Zach Swier's Catch-up GitHub project. So if you don't know who Zach Swier is, he's pretty well known in the Android community. I'll be putting all the references and the links to this stuff at the end of the talk in the last slide. And there's also a GitHub for this project, by the way, so you can find a lot more information. So whenever I shoot a reference like that, I've been careful to actually put it into the GitHub. All right, so now we have a pattern that will allow us to pretty much turn any kind of view events, like in this case, a button click, into a flow. So here, what we need to do is just call our clicks extension function or any other extension function we create for a view, call it onto the actual view object that we want to listen to, and it will give us a flow. So the goal here, though, is that for a complete view that has multiple elements, we don't want to end up with a ton of little reactive flows. Ideally, what we want is to have the conceptual view, like here we have a view that allows us to increment hearts and thumbs ups. And we want to basically only have one stream out of this, right? It's going to be a lot easier to manage. So we're going to see how to convert little flows like this into one aggregated one. So taking, again, the thumbs up button as an example, I'm going to start with my clicks call, and then I want to map this into one of those main view event types, in this case, thumbs up click. So when the user is going to press the thumbs up button, we're going to get a thumbs up click event that's going to come out of the aggregated stream. So it's a very similar process for the love it click button. By mapping the stream from our clicks flow to the love it click event, we're going to get the second piece of the puzzle right there. Just so. Now, we want to merge those two streams, as I mentioned. So how do we do that? What we want is to take a flow of, what we want to get is a flow of the parent sealed class for each of those individual events. So we can achieve this with this following little bit of code. You take the list of the two event flows, and we want to flatten them into a single one. So at the end of the day, in our main activity, this is what the code will look like. As you see at the beginning, we take the list of flows, and what do we do next? So the first step is that we're going to take the list of flows and try to turn it into a flow of flows. That's quite the mouthful, right? So the extension function asFlow provides us this conversion. And the reason we want this is that we can then use the flatten merge function to build that singular aggregated flow we've been talking about. So there's a lot going on here, but effectively flatten merge concurrently will collect all of the flows you give it, merge them into a single one. And then the only thing you need to note is that with flatten merge, you need to tell it how many flows are involved so it can aggregate them concurrently. The other alternates of this function will only do one after the other. So we want all the flows to operate in parallel and become one. All right, so that's how we merge different flows. Now, usually I'd like to make things a little bit more formal so that it's a bit easier to find yourself in the code of a generally bigger app. So here I've created a view event flow interface. It makes it super explicit what any given view, activity fragment, what have you, is going to generate as signals so that other components of your app only see this one pipe of events and knows that what's going to be contained into that. So in my case here, I look at an activity as a view, but in a more complex app, as you could imagine, you might have custom views, view groups, In Android, we also have something called fragments that allow you to compose bigger activities. So when you have all of these things, it's quite interesting to be able to really nicely split them up. So now we need to think about this stream of view events and how to transform these view events into intents. So as I mentioned earlier, intents, again, are these blocks of code that we want to apply on our model to modify our model and just get the whole cycle going. So we're collecting our view event flows. This happens asynchronously. So we're going to need, in this case, a coroutine scope to work with, as you can see in the sample code above. So I've set up a very naive lifecycle here. The idea is that I create the lifecycles, the scope, the coroutine scope, when we create the main activity, and when it's destroyed, we're just going to be canceling it wholesale, right? The trick is that when you cancel a coroutine scope, anything running underneath it will be canceled as well. So if you've ever played with RxJava, and I've mentioned subscriptions earlier in this talk, when you have a lot of subscriptions, at some point in the life cycle, you need to cancel them. So, and there's some tricks in RxJava to group them together and manage them, all of that. In the case of coroutines, what's interesting is that they have to operate within a scope, and when a scope is canceled, you get the cleanup automatically for free, basically. So now we have a naive scope lifecycle setup. If you had a proper Android app, you'd probably want to respect the different life cycles of Android and do it in key points in there, but we'll put that aside for now. So now we have a way of launching coroutines safely. So we need the coroutine scopes so that we can start processing events off of our view event flow. One way to do this, as I show in the sample code here, is to call the launch function on the actual coroutine scope, pass it a block of code that will run asynchronously. So here we do that. The important part here is to note that the collect function of our view events flow is what requires effectively a coroutine scope. This is the suspending function. So whenever we click on an event, we get a click on a button, a click event is emitted, it will be collected asynchronously. So by setting up this scope, we make sure that while the activity is up, whenever the user presses a click, presses a button, that click will be collected in that asynchronously in that coroutine scope. Every time an event comes in, the code block we will pass to on each will execute. We'll see in a second what goes in there. So this keeps happening until we cancel the scope, as I mentioned, which will close off our life cycle and cancels all the coroutines that we've launched under it. Right. This little bit of code, although it's not that many lines of code, it's kind of wordy. There's a nice flow extension function that can help us improve on this a little bit. It's called launch in. So by using launch in and giving it a scope parameter, we're going to be starting a new coroutine calling the collect function on this coroutine from the flow itself. So it's a lot less wordy, as you can see. We now know how to safely combine and consume a flow of view events. The next question in our MVI cycle is, how do we turn these view events into intents? So here I use an intent factory. Not only will this factory build our intents from our view events, but it's also going to be responsible for passing the intent itself along to our model. And again, well, yeah, we'll skip that bit. All right, so back to our MVI diagram. Now, before we figure out how to build our MVI intents, we're going to need to figure out how we're going to be managing state in our model itself. This is a key part of the MVI pattern. It's, I would say, almost the most important part of it. So back in our MVI diagram, before we can figure out how to build our MVI intents, we first need to figure out that model, right? The model is pretty simple. We just need to keep a running count of the number of upvotes for the hearts and thumbs up emoji. Data classes are great for models in Kotlin. First off, they're immutable. So that's like the nice feature that we want out of our functional type programming approach and reactive approach. The thing is, though, when a data class being immutable as it is, how do we expect to change state, right? How do we expect to be able to increment these counters? It's immutable state, so obviously you can't just +1 on the val, right? You can't move this. How can we change an immutable object? You don't. Data classes in Kotlin give you the copy operator. So with the copy operator, you can create a new copy of your data class, only applying the changes you want on top. So here in this example, we create a new state instance by taking an old state, incrementing the thumbs attribute on it by 1, and creating this new state. So to keep going here, we're going to need to make subsequent calls on top of the new state, which is now old. And in this case, copy it, add a increment the hearts counter, and so on and so forth. All right. So that's how our model is going to evolve. Now we can get back and talk a little bit about intents. Intents only do one thing. They take an old state and return a new state. As you can see here, an intent is an interface that declares a function called reduce. The idea of a reducer is that you take an old thing, apply some change on it, and then return a new thing. So in our case, if we wanted to implement an intent to increment the heart counter, this is one way we could do it. We implement the intent interface, and we make sure that it applies to the upvote model type. And here our reducer, the implementation of our reducer is effectively only this copy operator I just showed you, this copy function. And we take whatever we had before, we increment the counter by 1, and we get a new state out of it. So thinking back on our view events, then the conversion of these to intents with this kind of system is going to look something like this, right? It's pretty straightforward. So we're going to get a view event as a parameter. We're going to look up the types. What's nice with Kotlin as well is since we've defined this as a sealed class, which is equivalent to an enum, it's going to force us to make sure that we implement every single case in our when clause that you can see in the code sample. Okay, given all of this, this is what our intent factory itself looks like. So to formalize things a bit, we created the intent factory interface at the top. That interface only has one function called the process function. It's what the view event observables are being subscribed to. The process function is going to get invoked whenever a new view event is emitted. So we turn that into the appropriate intent. So we map the view event into an intent. And we send that over to something that's called the upvote model store. So at this stage, you might be going, what's a model store? How is it different than a plain old model? Why do we need this extra class in there? So I'm glad you asked. We can think of intents as little functions that we're passing around, right? So our end goal is to apply these little functions onto our model itself. And the model store is effectively where we make that happen. So on the input side, model stores receive intents and process them, very similar to the mapping we've just done with the intent factory layer. Model stores are also going to play another important role. On the output side, they expose a flow of model states. So we're going to first focus on the process input function. One thing you might have noticed with intents is that themselves, they're not very reactive. In fact, they're pretty much a mapping function on top of a bit of reactive code, which is our flow of view events. Intents factory, you almost get out of the reactive model, if you will, right? Like at the point where you start calling the process function, you're back in imperative land. You're just running these bits of code, which is fine because there's no real state being shared here. We're just preparing code and getting ready to pass it to the model state store itself. So yeah, so we're going to want to build up a stream of intents after we've passed through this intent mapping filter of sorts to get the benefits of the reactive programming approach and to fully basically benefit from it. So the way to do this in the model store itself is to use Kotlin channels. Channels are constructs that allow two coroutines to communicate together. So the idea is that a call to the offer function here of the intents channel will put up an intent for consumption for whoever is listening. And then execution keeps going. So if you remember the code samples from before, this means that our view events flow via our intent factory will complete execution after effectively calling the offer function on the intents channel right here. So whenever you get a click event from the Android view system, this will get converted into a stream of view events mapped out over intent, passed to the model store, and then the work is done. We pass the intent into the intents channel, we get back, and then the Android system goes back on its way. So very little work has actually happened right here. Now, before we actually start processing this new intent stream we have here, I'm going to show you how we'll be broadcasting our model state to the views that consume it themselves. So we use something called a conflated broadcast channel. It's another type of channel, but it's a pretty fancy name, right? So we're going to break it down and see what each bit actually means. So first off, it's a channel, obviously. So much like the intent channel I just showed above, you can send values into it, and then somebody can receive them from the other end. It's a broadcast channel. So unlike the vanilla channel, the idea is that let me just check my audio is good. My audio should be good. Please let me know if that's not the case. All right. My headset decided I fell asleep or something. Let me just double check everything is good. All right, awesome. So back with the show. All right. Right, so the broadcast part of the channel description here, it just means that you can have multiple receivers. So the idea there is that if you have a model, you're probably going to want a lot of views to consume it. In our case, we only have the one, but you have something a bit more complex. You might very well have 2 or 3 components, screen components that would feed off of this model. So you need a way to broadcast changes to everybody. That's the broadcast part. So the bonus points here is that you also get the as flow extension for free with this this construct. Wait, okay. Zoom just was capturing my clicks here. Right. So bonus point, as I was saying, is that with this type of channel, we get an as flow extension function for free. So we just get to expose the channel as a flow for everybody else consuming from it. This is nice because we're effectively hiding all the details of what we're dealing with under the hood. If you're the person doing the model store, this is very convenient. Everybody consuming from it doesn't need to know exactly what's going on under the hood. All right. And conflated, which is the last bit I haven't talked about yet, it only effectively means that the subscribers to your broadcast channel will only get the most recently sent value. So no buffering takes place. That's important because for Android developers, it's kind of easy to see. If you have your life cycle, your activities can shut down and come back. Your model survives these life cycles. And so whenever people come back and subscribe, you don't necessarily want buffered values, just want the current story and that's it. You don't want to get multiple events. So this conflated part of the name effectively just means that. All right. So we now need to figure out what the glue is going to be between those two channels in our model store. So the goal is to take a series of intents, change state by applying these intents one after the other onto our actual model, and then the results of this operation we want to send into the conflated broadcast channel. So that's the one line of code that binds these two together. It is, though, a pretty dense one, and it's probably, if anything, it's the key pattern of this presentation is really right here. We're going to be going through it and break it down one step at a time with a lot of little marbles in our marble diagram. So first off, the store's starting state is set at construction time. So in our case, we set the counters to 0. So that's just initialization time. When we create the model store, we're going to need to be able to set this to 0. Now, after that, we're going to get our first intent eventually when the user clicks on a button. When this happens, we're going to be calling the intents reduce, well, by calling intents receive, right? When we get our first signal, our first thumbs up intent, then receive, which is a blocking call of sorts, When you call receive, you wait on some data, and when the actual intent comes through, you get this intent and you can work on it. So now having this intent, we can call the reduce function on it, giving it our old value. So what we do here is that we take our conflated broadcast channel, quite the mouthful, our store, we take the current value, we pass it to our intent through the reduce call. And then by doing this, as I've shown earlier, we get a new state. This new state is going to be offered up on the store channel. By doing this, anybody that is subscribed to the store channel will get the updated version of the model. In this case, we got one more thumbs up. We keep doing this over and over again, and that is how state evolves in our reactive system. All right, awesome. So at the end of the day, that sounds like a lot of work, but you are seeing right here what a generic flow model store looks like. Very few lines of code. I think it's like something like, I would say 30, 40 lines of code. This is effectively the pattern you can use for any type of model store. Whatever you're storing in there, this is it, you're done. If you're familiar with Redux, very similar idea, very similar type of length of implementation, very small. So you might have wondered while I was going through my explanations why I actually used two channels here. So a few notes. The goal is to allow the process function itself to be called from any coroutine scope or context. Now, we didn't go through this yet, and depending on time, we're going to go through it in an actual live coding exercise. But the idea is that when you start working with this pattern, you're going to eventually want to do asynchronous work, like a web call, and use the result of this web call and feed it back to your model. If you've worked with mobile phones before, you know that the main thread is where rendering happens, and your network calls need to happen somewhere else. So we need to be aware that the process function can be called from another thread when we just got results from the web, for example. So that means that we need to basically apply the changes to the model outside of this thread. Thus, the two channels allow us to isolate this. If you look at the init block for this model flow model store, you can see that we use the scope, an internal main scope, and then that's where things are happening, and that's how we sort of re-aggregate everything back. All right, so the other thing that this means is that your reducers need to be lightweight. You will typically only do a copy on a state, so they should be very lightweight. You shouldn't be doing any type of heavy work there. Last thing to note about all of this, is that there's a close function right here. And if you need to ever shut down a model store, typically they would often be singletons in your DI. But if you do need to build them up and close them down again, this will get you all the cancellation that you need. And the channels are kind of nice there because they give you a nice way to aggregate everything. So between the channels and the scopes, the coroutine scope, we get a really nice, tidy implementation. Okay. When it's all said and done with this piece of code, the flow model store, it's very easy to define a new model store. You see exactly how our sample looks like at the bottom right here. The upvote model store is only one line of code. All you need to be aware of is that you need to pass in an initial state and you're good to go. So we've just closed. We just need to finish up our loop, and maybe if I can just double check with people, we have 40 minutes for this talk, right? Anyway, I'll get the answer on chat. I'll keep going. So the upvote model store, we need to be able to subscribe to that and show the results on screen. So how do we hook up our view to the model state observable itself, or rather, I should say our model state flow? So it's actually fairly simple. Here I've created my own little flow extension function where for each item received from the source flow, I'll be updating the counter text view, which is what we see on screen here on this mockup. So launching the collection of a flow is very similar in process to what we did to actually launch the collection of our view events flow. I put a lot of focus on the big picture here. At the end of the day, like sometimes it's hard to really get a clear understanding of a pattern if you only look at a presentation effectively. So another thing I like to do typically in these talks, especially about this subject, which is fairly dense, is I like to run a bit of to show people in the debugger how this pattern works in action. Now, let's let's see if I can figure out Zoom on timing. Well, somebody's gonna, I don't have much of an interface that tells me how much time we're supposed to have left.
20 minutes.
Sorry?
20 minutes.
Oh, that's awesome. All right, so we'll be going through the sample. We have all the time we need. We should only need 5-10 minutes for this, and then I can answer a few questions. All right, so let's get into some live coding. Yay, live demo. You know how it is. Things might go horribly wrong, but hey, we'll see. All right, so there we go. So I'm using Android Studio. I'm going to start off from the main activity. So my setup for test, hopefully this is visible. I tried to check my preview, so anybody stop me if it's not. I'm assuming it is. All right, so in our setup, we have an emulator running. We're going to restart this. This is a previous run. I have a nice little debug screen. We'll go through in detail what all of what's going on down there. So we're going to start off with the top main activity. Here, a proxy in our MVI for the view of the MVI, the V. So our main activity has all the components I've shown during the talk. There's a little bit more information here that just serves as a logger so that we can get a better feel for what's going on. On Android, if you're not familiar with Android, we have all sorts of fancy life cycles, but when we create a view, we get a callback function on create right here. This is where things start off. So I'm going to be putting a little breakpoint here. We're just going to look at the construction of the output and input streams effectively. And we don't really need to check what's happening on destroy, but we will be sort of interested in, well, a few more things. We'll want to see what happens when we click on a button, and we want to see the conversions from view event to intent, the model application in the model itself. So I'm going to jump in right now into our intent factory. I'm going to put a few breakpoints right there. So the entry point for all of this is the process function right here. This is what gets all the view events for our view or activity. Then we'll just dig into that, see how it converts. I'm just going to jump into one more breakpoint before we start the example. Start taking a little look at things, and that's on the model store side. Well, interestingly enough, the model store really doesn't do much. We can put breakpoints, and then we will, but really what we're interested in is when is the reducer being called? And we can even examine what the call stack is at that point to get a good feel for things. All right, so if I jump into last thing into the model store itself, right, we're going to set, well, we could set a breakpoint here just to get the illustration that when we start up the app, this is the first thing that will initialize our model. And then we'll set a little breakpoint in the process part right here. And finally, if we jump back to the main activity, what we'll like to see is how these events come back when the model has changed. So I'm going to set up one last breakpoint that is basically whenever something changes, this is the place that it happens. All right, now we've got everything set up. I can start my debugger. Now, the reason I'm going through this and I'm taking the time to actually set the breakpoints and everything, all of this code is available on GitHub, freshly released today for a new version for this conference. So I'll be giving the link to that in a few minutes. All right, so if we start our app, I'll bring up the emulator screen again. I'm actually going to do a little, there we go, something where we can actually look at the code while we're going on the app itself. All right, so Android Studio is building, typically not a super long project to compile, so we've got the startup going on. All right, the debugger is going to hook to our process. And there we go. All right, so first off, we see that our view, the main activity, is starting up. So we can basically get an X-ray vision of what happens on create. So this is the place where we set up our output streams, our output flows, that we also set up our incoming events. Nothing very dramatic here. Basically, if I step through the code, it just sets it up. All right, and so on and so forth. All right, so we'll just let that run. And once it's done, we see that the next step is that there's an initialization of our model store. Now, I'm being very bad here. If you know Kotlin, if you've noticed, I've used object earlier. So I basically set up a big nasty old singleton for examples right here, I believe. Right. Typically, if you're using DI, you want to manage singleton, which would be much better for testing, all sorts of good reasons. But whatever. All right. So here we're seeing it launch. This bit of code right here is basically what will make our model store active and be able to survive all configuration changes and everything like that on Android. All right, so that's basically done. Now we can see that for the very first refresh, when we subscribe originally, we do get the original state of the model, which is important because our counters are going to have to be set to 0, and we're going to get this data from the store when it's initialized to 0. That's what just happened right here. And there we go. We have our app started. All right, so to get a bit more of a feeling for this, we're going to actually increment one of the counters. So we'll press this button right here. All right, so we pressed on the +1 heart button. What's happening now? So if you remember, we have our intent factory. So the I in our, basically the I layer in our MVI. So we can see that our process function has been called. Now, one way to get a better feel for this, I'm just basically giving the big line so that if you do try it on your own later, you can basically go through the same process I'm just doing here. But to get a better feeling, you just look at the call stack right here, and you can see where things are interrupted, where execution is coming from. So we can see here that there's this invoke suspend spot on the stack, and really what's happening is that the event is being handled right here. There's more of the Android system above, but we don't really need to look at that much. All right, so being back here, we get a view event. What are we doing? Well, we report what that is in our logs, which we'll look at in a few seconds. Then here we're going to process our first event, but then first off, we're going to turn our view event into an intent. So we get into the toIntent function. We look at what type of view event are we dealing with. We're dealing with a love it click add heart. So we create a new intent, add heart. If the view event was carrying any kind of information, such as data typed in a text field or something like this, this is the place that we would pass it to the intent and more work would be done. But this one's pretty simple, so we're done here. Next step, we go into the upvote model store. We're going to call the process function on it. And now we're going to offer up that intent to the intents channel. So again, from the presentation, the intents channel right here is going to be the one that's going to be offered up this information. And when we're done, we're done. We're not blocking execution here. We're just like, okay, we're done. We just keep going. So as far as like the view event handling from the Android side of things is going, it passed a couple of layers, but effectively it's done. So the execution here is just backing back out. We're done. It's all over. The system will keep going. So we can just say, okay, run your course. Now, on the flip side of this, we have the model store. The model store just received an intent, so it's going to be doing some work as well. So here what happens is that we can see that the reducer is being called. So as I was explaining in that last diagram of the presentation, the intents receive call effectively was waiting there for something to happen. Something just happened. So we just got an intent, and on this intent, we call reduce, passing it the old value. So if I let execution run its course, we're going to normally see the right there, the intent itself, the reducer being called. And we can just validate this by going back up the stack, and we can see that, oh yeah, indeed, we're in part of the model store's process itself. There's a model store's coroutine, which is executing all of this. So at this point, we're going to be doing the operation, returning a new copy with the incremented counter of the state. And then the next step is we're going to be offering that up to whoever is listening on the store. So if I again let execution run its course, we're going to hit the next debugger breakpoint, which is updating the model, the view of the model. So we can see here with the debugging information that indeed we've incremented the counter by 1. Right, so there we go. That's the whole MVI flow. Now, at this point, a lot of people would ask me, Okay, that's all cute and nice, but you haven't actually shown us any type of asynchronous work, right? And there's a lot to go into. In this sample, there is an example of asynchronous work being done. This sample is extremely simple with the explicit goal of letting people understand this. I have another sample that I've done a course over at Caster.io about, which is also available for free for anybody, regardless if you're subscribed to Caster.io or not. And I linked to it in the talk slides, which is like a proper full-on application using MVI, not yet using Coroutine and Flow, but you can get a lot better feel for this. But as far as asynchronous works go, we have a few more minutes, so I'll show you what this simple sample is doing to demo how that works. So I won't dive into code right away. Well, except I will show you one thing. So if I go back to the intents factory here, so our intent factory had very simple intents to increment counters and things like that. There is a more complicated example which involves a bit of DSL, so that's also why I'm not going to dig into the code too much, except to maybe highlight a couple of lines right here. So the idea is that it is quite possible to create an intent that will do some asynchronous work of its own and launch web queries or do whatever heavy workload it needs to do in a separate thread, and that when it is done, itself can launch and actually feed a new intent into the model store itself. Right. So in this case, what we're doing is that we're going to be launching a separate coroutine scope in this dispatcher thread, which is basically just like CPU work that is not main thread related, so it doesn't impact the view. It shouldn't make our view stutter or anything like that. And what we're doing here is that we're going to be launching this fake WebSocket source, itself a flow, which will eventually come up with an intent after some work has been done. And then when this intent comes in, we're going to be feeding it back to the model store so that it can apply the work that is being generated from this slow running thing. So a bit beyond this talk, but there's this concept of side effects when you're talking about MVI. If you look at the different MVI patterns out there, there's quite a few interpretations. So honestly, I'm a bit different with my side effect interpretations of things, but not going to go into that too much. The basic idea is that sometimes you have work to do offline that will generate side effects, but this is just effectively saying, I'm going to run some stuff, and then when I'm done, I'm going to come back and potentially apply something new to my model. So the easiest way to show this off really is to rerun the app without the debugger, and I'll show you what's going on in the logs. All right, so I have this little button here, which is like this cloud, this idea of the cloud hearts, effectively. We're going to jump instead to the logcat for the app, and I'm just going to press this button, and we're going to go through the logs and just get a feel for what just happened. All right, so there's a few things that are going to happen. So this code actually emits every second a new +1, and it does that 3 times. So I'm going to read through it quickly just to get a feel. So first off, when we clicked on that button, our main intent view factory received the view event itself. It was told, hey, I just got this click, please process it. Now the intent factory does what it does. The first thing I would do is call the flow model store with a new intent. Now this intent is a side effect intent. It's an intent that actually did nothing to the model. Effectively, the model stayed the same, old was equal to new, and that was filtered out. So we didn't send a new event to the view. The model didn't change. The view's not aware of this, and this is fine. But what did happen is that the intent itself executed, and even though it didn't change the model, it did something. It launched this new job on the side, and that was it. As far as that intent goes, we're good. But what this job on the side is doing is that itself will generate every second 3 times new events, new intents, sorry. So what we can see in the logs right here is that when we start seeing these collect calls coming in, these are effectively simulating web queries that just resolved and themselves are generating intents that are then applied to the flow model store, which itself will reduce. So we're starting to see these hard cloud intents that were generated from this asynchronous process, this side process, that increment the counters by 1. And then the last line here shows us that the the view itself, the eye right there, actually did get this update, and things are good. So I think, yeah, and then we see that this event triggered 3 times. That's about it for me. So I'm just going to go back to the presentation, finish up, and give a chance to people to maybe, right. So this is, as I mentioned, the URL to GitHub. Are we doing on time? Are we?
Oh yeah, you're good. I reached out to you a second ago to let you know that you had 5 minutes left if you wanted to.
All right, awesome.
Yeah.
So, well, we'll just go through the links. So if you have the time now, screenshot this. So this is my GitHub. You'll find other samples there, but the main one for this presentation is definitely the upvote one. I try to keep it up to date. The thing to note is that this upvote sample has different branches. So the specific branch you're going to want to look at is the flow branch, if memory serves. You can find them easily. There's not that much of a history to this project, so you can to this GitHub repo, so you'll be able to find it pretty quickly. What other notes do I have? Yeah, I really like to insist with folks that step-through debugging is really an awesome tool. Use it. I mean, this pattern is actually, if you boil it down, very few lines of code. A lot of stuff happens, but when you master it, what's really interesting is that you end up being so much more productive. And once you start using it and you understand the underpinnings of it, you stop thinking about them. This stuff just works. I found that in my own project, it's simplified my code base tremendously. Yeah, and that's about it. So I'd like to thank everybody again. We'll
Awesome. Thank you.
Yeah.
That was great.
Thank you. If we have any questions, I'll toggle back to outside presentation. I'll start looking at my Slack and what's going on in Zoom. The other thing I should say to folks is that they want to reach out through GitHub, even write up an issue, asking questions, stuff like that on that repo. Like, that's a very nice way to reach me. Yeah. Cool.
Awesome. Yeah. I mean, if anybody has any questions, you have let me see, about 2.5 minutes to post them in the Slack channel. But if not, that's also fine. Actually,
yeah,
this was very thorough. I definitely enjoyed that.
Thank you.
I feel like you don't get, I always enjoy some actual running code. So.
Awesome. Like, tried to make it animated as much as possible, because I know how dry that stuff can be. I'll also just note to anybody still in the channel, like, I'll be observing on Room B. I'll be in there, and also you can just DM me on the Slack, and I'll be happy to answer any questions you have. So I'm not seeing any specific questions.
Yeah, same. We could probably probably wrap it up.
All right.
And then Oh.
So Jack, everybody, thank you so much.
Thank you so much.
Greatly appreciate the chance to do this, and yeah, it was awesome.
Alrighty. Thank you.
All right.
Etienne and everybody. Thank you guys so much.
All right, everybody, take care.